All right, we are back. This is going to be the last section that we're going to be covering in Chapter 5 before we move on to Chapter 6. Um, there are a few just kind of small notes that they make into full sections, and I'm just going to cover those really quickly here, and then I'm going to get into the most important meat of 5.6. 5.6 is called Inequalities with Triangles. Before we get to that, I just want to note something from a different section that we skipped. It's just two very quick and easy concepts. One of the concepts just says that if you had a line segment, any point that is the same distance from one endpoint as it is from the other endpoint, for example, here and here, or this one is the same distance, or this one is the same distance, any point that is equidistant from the endpoints of a line segment will be on the perpendicular bisector of a line segment. Okay. The other thing is, if it's on the perpendicular bisector, it will be the same distance to the endpoints. That was one of the things from the section we skipped. The other one just said if you had a point that was the same distance to one side of an angle as it was to the other, and if you drew all of those points that were the same distance from one side as it was to the other, like let's say that was 5 inches, that's 5 inches, 4 inches, 4 inches, 3 inches, 3 inches, and so on, those would be on the angle bisector. So any point that is equidistant from the sides is on the angle bisector. And if it is on the angle bisector, it is equidistant from the sides. That was a full section. I didn't really want to go over and make you guys watch a 25-minute video for that. Just know any point on the perpendicular bisector is the same distance from the endpoints of a segment, and the same thing with an angle bisector. Any point on an angle bisector is equidistant from the sides. Why is this helpful? Later on, when you're trying to construct an angle bisector, if you could go over and do 2 points that were both the same distance from the sides, you connected those, you would make yourself an angle bisector. If you were trying to make a perpendicular bisector and you could find a point that was the same distance from both of the endpoints, another one that was the same distance, and you connected them, you have a perpendicular bisector. So that was one of the sections that we skipped, as I said. What we are going to do now is take a look at the most important material from this section. There is one really silly part of the section and then two really helpful ones. The silly one just states this. We almost never use it, so I'm going to go over it very quickly. We know that the remote interior angles add to be the exterior angle together. So if angle 2 plus measure of angle 3 equals 1, this thing is really silly. All it says is that 2 must be less than 1 and 3 must also be less than 1. If it takes two things together to add to be equal to this one, then neither of those can be as big or bigger. They both have to be smaller. Once again, that is not all that handy. I just wanted to note it just in case it pops up, but it might happen like once in an indirect proof. Now, the most important part of this is none of this stuff. We're going to skip it. This is just examples of angle 1 must be greater than which angles. Let's move on to the more important stuff. Okay. Now, this is important. What this has to do with is trying to figure out how to determine if you are given 3 lengths, if you can make a triangle out of them. Okay, so basically it says that you have a side length of 4 and a side length of 8, and which one of these are possible lengths of the third side. Okay, now I want to show you why this one would not work. The reason why you cannot have one side being 4 and one side being 8 and the other one being 12. Think about this. If you had these little pieces of wood and you had 4 feet and 8 feet, and you tried to go over and make the last side being 12 feet, That just wouldn't work because those pieces would just sit on top of one another because 4 plus 8 equals 12, meaning you wouldn't even have a triangle. You would just have 3 sides on top of one another. Okay. Same thing why this one would not work. If you had a 4 and you had an 8 and then you had 13, that wouldn't work. And I'm not saying you can have a 13 and then 4 and 8 coming down like this. I'm saying that you have to use all of the length of the sides. So when you start thinking about this, we know that this one will not work because the 4 and the 8 will sit perfectly below the 12. Now think about this. If I went over and didn't have this being 4, it was 5. Now what would happen is you would have enough length with the 2 shorter ones where this would kind of pop out, making a triangle. Okay, you would have enough length so that they're not exactly, the 2 shorts are not equal to the long. Now they're longer, so you would have enough for this to be able to pop out and be a triangle. Okay, so basically, let me go ahead and just jump straight over to this. What this theorem says is that the sum of any 2 sides, I'm going to make this easier for you guys. The sum of the 2 shorter sides, the 2 shorter sides of a triangle must be more than the long side. So that's basically the rule. The 2 short sides cannot add together to be equal to the third side, because then that would be like a length of 1, a length of 3, and a length of 4. That doesn't make a triangle because you don't have enough length here to go over and make it pop into being an angle. Okay, it would just sit perfectly up against the 4. What ends up happening is the 2 short sides must add to be longer than that long side, right? So here, this side plus this side must be adding together to be more than that one. So if I gave you this right here and I said, here are 3 lengths. Can these be the 3 lengths of a triangle, the sides of a triangle? All you would have to do is say, do the 2 short sides add to be longer than the long one? 3 plus 6 is 9. Is 9 bigger than 10? No, so it's not going to work. A visual would be if this was 10, here was 3, and here was 6. It's just not long enough for the 2 short sides to pop up to be a triangle. It's not even long enough for it to be the same as the long side. So that would not work. On this one, try to add these. These are the 2 short ones. 1.9 plus 0.31 gives me 2.21. Is 2.21 greater than 2.23? Nope. So that one's not going to work. What do I need to do? I have no idea what that length is. I'm going to grab a calculator. Check. And where would a calculator be? You guys hide my calculator? My first year of teaching. It actually wasn't my first year of teaching. It was student teaching. All the kids thought it'd be real funny to hide all of my whiteboard markers. That way, when I tried to write on the board, there were no markers, little punks. Okay, I found a calculator. Square root of 140. Okay, square root of 140 gives me approximately 11.8. Okay. Do the 2 short sides add together to be bigger than the third side? 4 plus 8 is 12. 12 is bigger than 11.8. Yes, that's a possible triangle. 2 times rad 47. 2 times rad 47. That gives me 13.7. 13.7. Do the 2 short sides add to be longer than long? Is 20 greater than 13.7? Yes. So these are possible side lengths. All right, let's keep on cranking. Now this gets a little bit more confusing. This says, if these are the two lengths, what are the possible lengths that the third side could be? So this is how we would do this problem. Step one is just assuming that those are the two short ones. If those are the two short ones, they add to be 10. So my third side would have to be less than 10. And now the other thing is, assume that this is the long side. If the long side is 8 and one of my sides is 2, then the other side, the other short side, would have to be larger than what number? 6. Can't be 6 because 6 plus 2 equals 8. It needs to be more than the third side. So any number that is greater than 6 and less than 10 would work for the third side here. You probably are picking up on, make an X, go like that, add them together, put that number here, subtract them, and put that number here. 8 minus 2 is 6. Okay, let's go ahead and do another one. I'm going to do it the long method, and then we'll take a look at the shortcut. If this is the long one, then that means that the other short one must be greater than 14. Can't be 14 because that wouldn't be enough, so that they add to be greater than the long. Next, if those were the two short ones, then the long one cannot be what? It has to be less than 24, because these together are 24, so it must be less than 24. Shortcut, add them together, subtract them, ta-da! That's the shortcut. Okay. All righty. Use the following triangles to develop a conjecture. Okay, if we looked at this, 30 degrees over here, 60 degrees over there, and that's 90 degrees. 1, 2, and 3. Let's see. Let's say that this right here was 1, and this over here was 2, and this length over here was about 1.7. What seems to be true? If we're trying to compare the sides and the angles, notice that that's 60, that's 30, and that's 90. And then this one is 1, 2, and 1.7. Don't worry about the actual exact numbers. Try to come up with a conjecture. What do you think is always true? Across from the biggest angle is what? Across from the biggest angle is the longest side. Across from the smallest angle is the shortest side. Across from the medium angle is the medium side, because we have a short side, a long side, and a medium side. So there you go. That is basically your theorem there. It basically says, let me see if that is, let's see if we have a nice, let's look at this really quickly. Angles and sides. This is an inequality. It basically is saying, when I say inequalities, it's because you have the greater than symbol. It says, in any triangle where all the measures of the angles are different, the longest side is opposite the biggest angle. The shortest side is going to be what? Opposite the smallest angle. Okay, so if we know that that was the biggest angle, then across from it will be the longest side. BC is going to be greater than, now we know that B is the next biggest angle, so AC will be the next largest side, And if C is the smallest angle, then AB will be the shortest side. Across from the biggest angle is the biggest side, across from the smallest angle is the smallest side. Okay, so let's take a look at this. If we were trying to figure out the sides from shortest to longest, how would we do this? Well, here we only have two angles. Let's figure out what the third angle is. 180 minus 58 minus 62. And that gives me 60 degrees left over. What is the shortest side? It's across from the smallest angle, so TV would be the shortest. What's the next smallest angle? 60. So across from it, UV would be the next smallest side. And then across from the biggest angle, TU would be the longest side. Okay, what I want to do here is if we drew triangle ABC, A, B, C, we knew that A was 80 degrees, and we knew that B is half of C. So that must mean that that is the, how many degrees do we have left? We have 100 degrees left. And we know that this one, B is half of C, all right? So how is it possible for that to be true? Well, that must mean that B is 33 degrees approximately, and this one is 66 degrees. Now what I want you to do right now, tell me what is going to be the longest side given these angles. The longest side is CB. CB is going to be the longest side because it is across from the biggest angle. Now, if we're actually going to follow through with what the problem is asking, what is the shortest side? Across from the 33 is AC. Across from the next smallest angle is AB. And across from the 80 is the CB. So I hope that makes sense. Triangle MNP, where angle M is that, let's go ahead and skip this problem right here. Just make sure you understand that across from the smallest angle is the shortest side, across from the biggest angle is the biggest side, across from the medium is the medium. Now, I want to think about one last thing. That is this. A little corollary. How does this connect to isosceles triangles? Well, isosceles triangles have two congruent angles, so how would that work with this? Does that follow along? Does that work with our net of knowledge in geometry? Well, yes. What do we know? If that angle is congruent to that angle, what does the converse of the base angle theorem say? Those must be congruent. Since both of the angles are congruent, then the sides opposite them must be congruent, which goes along with across from the smallest angle is the smallest side, basically that there is a connection between the angle size and the side opposite from it. Think about this with equilateral triangles. If all of those sides are congruent, then what should be true about all of the angles across from those sides? They should all be the same, right? Because there is no biggest, there is no smallest. They're all the same, so all the angles should be the same as well. All right, let's go ahead and scroll through this one more time. And by scroll through it, I mean I'm just going to give you a little summary. The summary is that short side plus short side must be greater than the long side. That must be true for any set of sides of a triangle. For example, 3, 4, and 5, the two short ones add to be 7, and 7 is bigger than 5, so that's possible. If it was 3, 1, and 5, two shorts do not add to be greater than, so therefore this is not a possible triangle. That was one important part of this lesson. And the next one was just across from the Largest angle is the longest side across from the smallest angle is the smallest side across from the medium is the medium. Hope that made sense. Come to class with questions. Thanks for watching.